All right, now we're going to take a look at how to do a hypothesis test if we are comparing two means. So our test statistic is here, and this follows a t-distribution. The degrees of freedom are calculated using this equation, not a simple n-1. There are some fields, some books that will allow you to use n-1 for the smaller sample size. However, for the most accurate answer, the most accurate p-value, we want to use this degrees of freedom. So because we're going to be using this crazy degrees of freedom, we are not going to be doing any of this by hand. We're going to let Excel do all the work for us because this is already programmed into our Excel spreadsheet. So the example we're going to look at, the Space Lab Life Science 2 payload sent 14 male rats to space. Upon their return, the red blood cell mass in milliliters of the rats was determined. A control group of 14 male rats were held under similar conditions except for the space flight as the space rats, and their red blood cell mass was also determined when the space rats returned. The project resulted in the data listed below. Does the evidence suggest that the space rats have a different red blood cell mass from the control rats at the alpha equals 0.05 level of significance? So we have 14 male rats that went to space and 14 male rats that did not go to space that we're using as a control group. And we want to know, do the two groups of rats have different red blood cell masses? So did going to space affect the red blood cell mass of the rats? Is that something that we need to be considering when we send people to space? Is that it would affect their red blood cell mass when they return to Earth? Or are they fine? Does space have no effect on it? These are things we need to know. So this is another case, and we have alpha equals 0.05. So this is another example where we have been presented with raw data instead of given the mean and standard deviation. So what you should do is you should go ahead and use your summary statistics to go ahead and find the sample mean for the space rats. And if you do that, you would find that it is 7.8807. And the standard deviation for the rats that went to space is 1.0175. And I'm going to call this group 1 just because they're on the left and I saw them first, so they're group 1. Doesn't really matter so long as I'm consistent. Space rats are always group 1. My control rats are group 2. So go ahead and calculate their sample mean and sample standard deviation, which I have that right here. So their sample mean was 8.43, and their sample standard deviation is 1.0055. And then both groups contain 14 rats. You don't always have to have the same number in each group. You can have a different number between the two groups, that's fine. We just happen to have the same number in the two groups in this case. So we'll go ahead and write out our null and alternative. Oh, you know what? We have one more number. Let's go ahead and write that down actually. We do already have it here, but it's nice to see it. It's nice to write it down. Alpha is 0.05. So now we'll go ahead and write out that null and alternative. So null and alternative always starts with an HO and an HA. So now we're going to start by assuming that the spaceflight had no effect. So the means between the two groups would be the same. If I were to send every rat into space, there would be no difference between their mean before and after flight. The alternative is that the mean of the first group would be different. We don't know if the space flight is going to increase or decrease their red blood cell mass. We just want to know, is it different between our rats in the control group? If it was less than, we would use a less than symbol. If we thought that it was decreasing their red blood cell mass, we would use a less than symbol there. If we thought beforehand, hey, maybe it's increasing their red blood cell mass, we would use a greater than symbol in this alternative hypothesis here. But we don't know. We just want to know, is it changing their red blood cell mass? That's really what matters. Is it different when they get back? Because we have to account for that then. So we're going to find our test statistic. And our p-value. And we're going to use Excel to do both of these. So I'm going to go ahead and open up my Excel spreadsheet. Maybe. There we go. And I already have it loaded to the 2 sample test means. It's right next to the 2 sample test proportions. I'm going to slide this over just a little bit and zoom out. So at the top of the page here, we can see mu1 equals mu2. Right now it's set up as mu1 is greater than mu2, but that's not what we actually want to test. We want to test if mu1 is not equal to mu2. And then I went ahead and I already entered in the means and standard deviations for each of our 2 groups. Make sure you keep all of the 1s together and all of the 2s together as you do this. We have the standard error, we have our t-score, our degrees of freedom, some critical values that you would use if you are using the other method besides the p-value method. That's the method I did not go over, but you were welcome to learn on your own. And then our p-value. So we want the t0, that's our test statistic, negative 1.4368, and our p-value, 0.1632. Once we have those, we can go ahead and write our conclusion and our interpretation. So for the conclusion, I want to know, is my p-value too small? And I determine what is too small by comparing it to my alpha. Are the probabilities of these results too small? So is 0.1632 less than 0.05? No, it is not. So if P is not low, we do not reject the null. We cannot prove our theory that the space flight is affecting the red blood cell mass, which is actually probably a good thing. So we do not have enough evidence Remember, our evidence is our p-value. The evidence for our alternative is a small p-value. We did not have a small p-value, So that means we did not have the evidence we needed. So we do not have enough evidence to support the claim that I just want to make sure I phrase this well. The space rats will have a different red blood cell mass than the control group rats. That's what we were trying to prove. We did not have enough evidence to support that claim. So I'm going to read that sentence again. We do not have enough evidence to support the claim that the space rats will have a different red blood cell mass than the control group rats. And that's what you need to do to compare two means.